All right. Great to see all of you folks here. Very nice to be back with, of course, featurestore.org and HopsWorks. So just a quick introduction, as Jim mentioned, my name's Aman. I'm a product manager at Arize. We're an ML observability platform. We'll talk a little bit about what that means. And a bit before that, I was actually at Spotify working on the feature store infrastructure and feature store API. So pretty familiar with the feature store space and challenges around, defining the difference between the data of the feature and versioning the transformations on that feature, the offline online challenges, point in time joins and backfill. What we're going to be talking about is actually once you feel like you have the feature ready to go, once it's ready for production, what happens next? What happens when that feature is actually integrated into a model? And what are some of the downstream challenges that potentially your customers or yourself, if you're the producer of these features, might be facing that can actually undermine the value of that feature at the end of the day when it comes time for that feature to actually start being used, to start making inferences at scale. And that's really the core kind of challenge that we're focused on at Arize. And we'll start with actually kind of a high level. What are some of the problems with production ML? And just so we're all on the same page. And then from there, we'll start talking about this category around feature store monitoring and feature store observability, and the ways that we actually assess and evaluate features to actually, surface up the insights of what are the problems that might be going on underneath the hood with either your model or the features and the data themselves. So kind of just talking about a high level, there are many steps that either your customers or if you're a model builder, you'd have to go through to actually get your model into production. There might be actually significant changes in how the feature is defined, be it you might have to rewrite potentially the logic of the feature to actually make it production ready for at scale. And the sad truth is that even after all of these steps, once your feature actually starts getting into the model that's in production, there could actually be some downstream challenges that due to the underlying nature of the world that the feature is operating in, the world the model is operating in, that can, could be due to human behavior, things like sentiment changing. COVID is another big reason, of course, as well, that a lot of models were basically producing outputs and inferences that just weren't representative of the real world. And a lot of those issues actually fail silently. And that means that, business KPIs can be impacted. And then by the time that an issue actually shows up in the form of feature drift or performance drift, by then it's actually, it's very quite difficult to actually troubleshoot and triage what the root cause of that failure was. And so really there are multiple steps here that kind of go into, actually correlating that business metric and the sort of business impact of a model, going back to the individual model performance, and then actually identifying the sort of root cause or slice that could be impacting that model performance the most. So not only are there a ton of challenges to get the feature and model into production, but the path after that is equally, if not more difficult as well. And so just to start with a little bit around the definition of what we're talking about with observability, we're not talking strictly about monitoring, but actually the underlying sort of understanding of how to fix your features in your model when things break. So, monitoring could be as simple as telling you, hey, there's an issue with this feature, but to actually go deeper and assess and evaluate, be it structured or unstructured data like embeddings, what the root cause of that issue is really what we kind of qualify as observability. And that's really what we're going to be talking about. So just to kind of summarize that back up, observability is just, the monitoring is sort of the tip of the iceberg, and observability is what gets you to that root cause. And for the most part, what I'm going to be talking about is going to be relatively at that sort of higher level of just concepts and themes. But to go any deeper on any of these subjects, I'll actually be dropping a link towards the end of the talk for you to actually sign up for Arize and sort of see, if this platform kind of meets your needs. And then we have a ton of documentation as well that can kind of go deeper on any of these subjects. So where does the feature store kind of fit into this whole thing, right? So, I mean, this is a feature store conference. We view feature stores in sort of the same level of importance as, say, your model store, as well as the inference store that we're kind of talking about, which is really once the feature is created, once you have that offline and online definition, you then kind of pass that on to the model for either for training or when it comes time for serving. So you have that notion of that feature, the definition of that feature, kind of passed along with the model, sort of underlying metadata of the model as well. So that could be what type the model is, what the sort of the architecture of that model is. And then when it comes time to serve those inferences online or in batch, that's where the inference store really starts to become valuable, because at that point, we then log the actuals associated with what happened in the real world and correlate and sort of actually join those along with the inferences that the model made and all of that underlying feature metadata and feature data itself as well, not just the metadata. And from there, that's when we really start getting to the value of observability and actually sort of slicing and dicing even further to show you value. So why does all of this matter? Well, at the end of the day, what we realized is that we actually went out and surveyed around, roughly about 1,000 companies or so and got data and found that when issues do occur, it takes roughly about a week for engineers that own those models to actually detect and fix the issue. And so to go deeper, roughly about 50% of engineers we spoke to said that they actually lack the tools to do this root cause analysis. And on top of that, the sort of end impact here is that businesses don't have visibility into their return on investment in machine learning, as well as, when issues occur, how to kind of correlate that back to models. So that sort of stitches all of this together. At the end of the day, it impacts your business, it impacts your users. And so understanding what's going on underneath the hood is kind of critical to the feature store being successful in a production environment. So with that, let's jump into what I'm talking about when it comes to feature store monitoring. And there's really kind of three concepts I want to talk about, which are data quality, drift, and performance. And we'll kind of break down each of those as we go. So data quality, what do I mean by that? So data quality is really what you can imagine as sort of at the sort of highest level, at the top level, it's really the sort of pipeline issues that you might expect from the data itself. So when you set up a data pipeline, there are many things that could go wrong. And a couple of the common issues that we see right off the bat are missing data. So, let's say you have a model with 300 features. One of those features was the app open or not, hypothetically, in some sort of, batch serving model of, should we serve an ad or not? And in that case, because of connectivity issues, because of pipeline issues, because of database issues, you may not actually even realize that you're missing data. And in that sort of way, that's like the highest level problem, but there's many types of problems in that domain, from things like out of range violations. We might be getting data that's just not within the bounds that we expected it to even like type mismatches. All of these really get caught under this umbrella of data quality checks in production. And so the way that we kind of approach these issues is we really ingest at least at Arize, and when it comes to observability, the goal is to really kind of take all that data and profile it and look at what are the sort of common values that we would expect. What is the expected based on a good period of time for this data to look like? And from there, you actually set up monitors against all of those threshold values. So we actually have models underneath the hood producing these thresholds. And from there, you actually get kind of notified or pinged either through Slack or PagerDuty when any of these issues occur above the threshold. Let's say we're seeing more missing data than we expected it to, 1% of nulls as opposed to 0.1%. That would then page you and alert you to go and check on the data quality of an underlying feature. So that's really, we kind of view this as, the sort of maintaining that contract between you as the model owner or the feature producer with your upstream data quality teams, where they're kind of responsible more for the logging pipelines and maintaining the quality and integrity of the data pipelines themselves. But that's just really kind of the start. That is really sort of just at the highest level, is the data even good going into the model? One layer deeper than that is when we start getting into what we call drift, which is looking at the underlying distribution of that data and profiling that distribution of the data and seeing if that data or that distribution is changing over time. So let's say I have a reference distribution. In this case, it might be my production model for the last week. Really, it would be important to be notified if that reference distribution is significantly different from the baseline. Let's say that's either my training data set or it's my production data set from a week, maybe a month ago. If all of a sudden the environment that my model is operating in is markedly different, that's something I'd want to be notified of. So in this case, we kind of view data drift as one level deeper than the data quality of the pipelines themselves, and more along the lines of a potential proxy metric for highlighting, perhaps a number of data quality issues that might be still underneath the hood, might be underneath the thresholds, but are causing this sort of change in distribution. Or it can also be a signifier or some sort of alerting to users that that your model might need to be retrained, that the environment that your model is operating in is now different than when your model was trained, or in production data, perhaps sentiment has changed. So drift is really kind of a bridge in a way of almost a proxy metric of, is this model operating in the same world that we expect it to based on our offline or online understanding. So it's very common. We catch drift issues quite significantly, even at sort of what you'd expect to be top tier ML companies. And part of the reason for that is because understanding how to quantify drift is actually a pretty difficult statistics problem. And so there's a number of ways, we've surveyed and spoken to a number of teams. We have a number of customers that, look at, all of them have different kind of methods for evaluating drift. And really they're for certain features, for certain metrics, there are certain approaches to evaluating drift that might be stronger than others. We found that generally PSI, which is Population Stability Index, is a pretty kind of good general approach to measuring and quantifying drift. However, there's a number of other approaches you can take. And really the trick here is to understand, based on the distribution and feature that you care about, what does drift mean in that case? And that's kind of hard to do just in the, sort of the highest level, like is this feature drifting or not, is a question we get a lot, even when we're evaluating models. And the answer to that is, it really depends. It depends on the case. It depends on the performance of that model. And so that way we actually look at sort of this funnel of drift and data quality kind of leading ultimately to performance. And that's really what, at the end of the day, what matters. It's the performance of the model, the accuracy, precision, how you define if that model is performing correctly in sort of this environment, and then kind of working backwards to see, is drift a potential problem here, or is data quality an issue? And from there, you can start drawing correlations between those metrics and start understanding, what does drift mean in your model's case? Of course, even within our platform, we do, again, offer sort of those automatic thresholds for drift to get you started when you just get your features ingested around, just monitoring features. Let's say if I don't even, let's say in this case, if you're just responsible for the feature store, you don't have that access to the downstream performance data. That's still something that you could be alerted on, that the underlying distribution of your feature has changed. And that's something that you may want to notify your downstream, let's say 10, 20 data scientists, that they may want to look more closely at the performance of their model and see if there are any changes. And that may also be, a good proxy if you don't get actuals back in some cases, or the actuals take a very long time to return. Drift can sort of preempt some of the downstream performance issues that you might see. So we generally kind of view this as correlated. And I did notice a question come in, and I'll save a little bit of time at the end for questions in the next few minutes. And so really, that's really kind of the last sort of what we call pillar here is understanding explainability, fairness, and kind of tying that all together. And so when we kind of look at and view as explainability as, when it comes down to the feature and underlying feature slices themselves, how much are those features contributing to the model's overall performance? And kind of going one layer deeper than that, what is the relative sort of importance of these features to each other? And so really what these histograms are meant to kind of demonstrate on the right-hand side is, based on the volume of an underlying feature slice, which we define could be either a range, or if it's a categorical feature, it could be, in this case, different types of animals, something like this. Then you can actually see, based on the impact of that feature, based on the volume and contribution to the prediction. So that's really kind of how we view this explainability, and kind of going even one layer deeper than that. We've kind of identified that there's actually a way to sort of stack rank these slices based on that sort of overall impact on model performance. And that's usually a pretty good way to start burning down what are the feature slices, even if the overall feature looks good, that might be impacting the model performance the most, to go and kind of understand, am I missing data? Is this data different than what I trained the model on? And so that's really kind of the in a way kind of getting to the root cause of how much a feature slice is impacting a model's performance. And so just to kind of summarize that up, what we recommend when it comes to performance tracing is actually compare to something that compare to a reference distribution, so that you can monitor effectively. And then you can actually from there compare and break down the features by slice. So that can usually be a great way to troubleshoot and root cause. And from there, actually being able to, look at points in time and compare these values. That's really the steps that we recommend following when it comes to identifying and kind of going deeper down the ML performance tracing workflow. And all of that has generally been around structured data. I'm going to briefly touch on unstructured data or embeddings. And so, in the case of a feature store, many of these cases may also, many of these feature stores may also be housing unstructured data in the form of vectors, nearest neighbors vectors or user vectors. And so what we recommend is, you do kind of take a similar approach where you want to monitor every embedding the same way you do with your features. You look at patterns of change. And then from there, what we actually enable is exporting out the problem segments or problem cases here, where drift may be correlated back to a part of your unstructured data looking markedly different. And so we actually take the same approach, but what's maybe and sort of just kind of double clicking and sort of like what are embeddings. They're effectively just this mathematical representation of data from some vector space, and they could be either high dimensional or low dimensional vectors as well. And so in this case, if we take like a word embedding, like man is to woman, what king is to queen, from there you can actually visualize that vector space and actually be able to cluster around segments that might look markedly different than the training and production sort of distribution of this high or low dimensional vector space. And so in this case, what we're kind of showing is different colors correlating to different data sets, and then actually looking at outliers here for something like a text vector that represents sentiment of reviews. You'll see that actually a number might be clustered around great or didn't like it, but there might be a training in part of the training set that might look different, or even production data set in this case that might look different than the training data set, which is a different language than what we expected to sort of train the review model on. And so to actually visualize unstructured data is a whole nother challenge. It's actually one that we do enable in the product as well. We use a sort of a technique called UMAP, which actually takes these sort of vectors and actually compresses them down to a lower dimensional sort of visualization space. And so you can actually kind of view this in 3D and actually cluster different sort of data points within this unstructured data set, and then go and export those for your labeling. So we basically fundamentally we do take the same approach in our sort of structured data as we do in unstructured. It's just that the tools that you might utilize can look a little bit different. So kind of tying it all together, we touched a little bit on what is observability, how does the feature store fit into this sort of storyline, and then what are the different approaches that you might take to monitor features. And in summary, really what we're kind of getting at is just to stay focused on your customers and data science use cases. At the end of the day, the adoption of your feature store means that you want to make sure that the quality of the features that you're providing to downstream customers, or the quality of the features that you are in charge of managing, are as high quality as possible. And so it's imperative to actually monitor those features using ML observability as close as you can to the business case. And then that really helps you kind of hold your upstream teams accountable as well when there are issues that occur when it comes to third-party vendors or your upstream data pipelines, when that could be an issue with the feature, but it's actually root cause to a data quality issue, or just requires a model to be retrained. And then that really what we kind of sort of recommend is looking across data quality, drift, and performance metrics to perform that root cause analysis when issues do occur, because what we've seen is it's really just a matter of time, and having the right tools ready is what will make your feature store be prepared when it's ready, when it comes time to actually ship the feature in production. So that's a bit of a high level on what ML observability is and applying that towards the feature store. Welcome to sign up for a free version of Arize. You can sign up for a free account, start ingesting your features or ingesting your feature store as well and playing around. Feel free to give us feedback in our community Slack as well. But thank you so much for your time, and I'll be sticking around for any questions as well as the next panel.